Okay, let's get into everyone's favorite topic, and that is algebra word problems. And I know a lot of you are like this. Oh my goodness, I love algebra word problems. I just can't get enough of them. But I'm realistic. Probably 90% of you out there have this kind of face, or like, I don't like algebra word problems. They're so hard. They're so confusing. I wish I could just do math and not deal with these word problems. Listen, I get it. I was a student way back in the good old days, back in the 80s and stuff, and I'm pretty sure I felt the same way about word problems. But typically, students will feel that way about word problems because they haven't really built up their skills yet, their math skills. So they're struggling with the basics and the fundamentals because word problems are just an application of the skills that you're learning. So you're going to get better at word problems if you get better at your general math skills. Okay, so if you're studying algebra, then the stronger you are in algebra, the better off you're going to be in algebra word problems. It just makes sense, right? So if you know that you don't understand a lot, get away from the word problems and go back and strengthen your skills and then come back to word problems. But there's no need to have a sad face. We can turn these sad faces into a happy face, and that's going to be the objective for this particular video. Now, the subtopic here, well, obviously we're dealing with algebra, we're dealing with the word problem, is systems of equations or systems of linear equations. So along the path here, as I get to go through the solution, if you feel like you need additional help with systems, then you could pause the video or just finish it out and then check out my systems videos. I have a lot of videos on systems in my algebra playlist. So I'm going to give you some other general advice here in a second. But first, before we get going, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over several years, I've constructed what I like to believe is one of the best online math help programs there is. Of course, I'll let you be the judge of that. If you're interested, you can check out my math help program and find the link in the description of this video. But basically, I have 100 plus different math courses, all right? I have all the big courses like pre-algebra, algebra 1, geometry, algebra 2. Going to be launching my pre-calculus course here soon. Very excited about that because it's taken me years to construct. All my courses are not little short tutorials like, hey, let me just whip up a course. No, these are comprehensive, real deal math courses, okay? So, I only put out a course when I feel great about it. So my courses are, of high quality, but I also have, beyond those basic courses or those general standard courses, I have many specialty courses for test preparation. So if you're preparing for a test like the GED, SAT, ACT, GRE, GMAT, teacher certification, nursing entrance, Accuplacer, ALEX, CLEP exam, you can see there's a ton of tests out there. Very, very important tests for people's goals and objectives and career paths that people have to get through. And there's a lot of math on these particular exams. So I have very special test preparation math courses. So you can check out my course catalog on my site. I should have your test that you're taking. If I don't, drop me a line and I'll give you my best suggestion, or maybe I'll even make your test preparation course. Now, I also do a lot with independent learners like homeschoolers. I have a homeschool learning system. So if that is where you're at, you want to check out my program there. And then obviously, I help a ton of people who are struggling in their class. They have, these sad faces. Maybe they don't like their teacher. That's a standard thing. Or like my teacher, I wish you were my teacher. Well, listen, you want to get the best. You want to find someone that, you like to learn from. But sometimes you don't have an option if you have a teacher. And, and I don't like to say that there's bad teachers. Like, maybe you just don't connect with your teachers. But are there bad teachers? Yes, of course. There's bad everything in this world. There's good and bad. But you need to take the initiative to do what you have to do well in math. Okay. And the number one thing you can do to help yourself is take great math notes. Okay. This is just a top thing you have to do. I kind of call it a math law of the universe. So over decades of teaching math, one thing is apparent to me. Those students who take great math notes almost always end up looking like this person at the end of the year with their math grade. And then the reverse is true. Those students who don't take good notes, sloppy notes, they're like, maybe they don't even take notes. They're like, I don't need to take notes because I remember everything I see. Well, I've heard that one 1,000 times. And then guess what? That person's like, I have a photographic memory. Oh, well, I hope they remember their grade because they're going to be looking like that at the end of the year. Don't Don't be, one of those people who are like, look, I don't have to write things down. I just like, I don't have to study, and somehow I just pass these tests with A's. Yeah, I hear that all the time. It never really ends up working out in the end. Okay, you got to take great math notes. That's a skill. It requires work. It's going to keep you focused. Okay, but as you're improving on your notes, you need something to study from. So I offer detailed, comprehensive math notes to include pre-algebra, algebra 1, geometry, algebra 2, and trigonometry. You can find links to those notes in the description of this video. Okay, so let's get into this word problem. Now, here it is. And let's just talk in general. I've done other videos on word problems. You can check those out in my algebra and pre-algebra playlist. But and also, I think I've done some, I do so many videos, so just check out my various playlists, but definitely in my algebra playlist, you'll find other videos on word problems if you want to, practice more word problems, which you should be. But basically, the steps in order to solve a word problem is one, you have to read the problem. Now, a lot of you are like, okay, Mr. YouTube man, read the problem. That's not really helping me out. That's obvious. No, I mean, I really mean this, okay? This is like the first step. You have to read the problem. How many times? You're probably going to have to read the problem like 5 times, okay? So we're going to have to read the problem, keep pulling information out of the problem. So you just can't read the problem once and then try to solve it. That doesn't work, okay? So I'm going to show you what I'm talking about here in a second. The second thing is we need to create some sort of model of the information. And this could be some sort of geometric model, a chart, a table, anything. We need to kind of represent this information in an organized way such that we can do what? Well, we want to be able to set up an equation, but we can't set up an equation until we assign some variables. Okay, so this is algebra we're talking, right? So variables like x, y, w, z, all these different things represent something. So we have to assign some variables and what's going on. What we're trying to answer. The unknown value is what we're trying to answer in a problem. So that's good. That's what your variables are going to represent. And then if we assign variables, we need to solve for those variables. That means we're going to have to set up some sort of equation, and then you have to have the skills to solve that equation, and then we need to answer the question. Okay, so just because you solve the equation doesn't necessarily mean that you have the answer to the question. Okay, this is again one of those things where students rush the process and they don't think. So this is kind of the general format of solving algebra word problems. Okay, and I use the word general because every word problem is a little bit different. But effectively, though, this process is pretty much what you want to follow. Now, with that being said, I would encourage you to pause the video and try this problem real quick, okay? And obviously, I'm going to do this here in a second, but let's just read the problem and then I'll get into the solution here. So it says, a store sells 2 sizes of wood stain, okay? And if you don't know what wood stain is, it's a little can with a little paint stuff on it. You take a little rag and then you fix up your wood desk and it looks prettier. So that's what wood stain is. All right, so a small can sells for $8.95 and a large can sells for $15.95. Okay, so one day the store sold twice as many large cans as the small cans. So if the total revenue, and by the way, this word, you got to know what this word means. Revenue is your total sales, okay? Total sales for the day. Minus your not counting your cost, right? But you just need to know that's like the gross sales. So if the total revenue that day for these cans was $694.45, how many cans of each size were sold? So that's the problem, and you are given this hint that we're talking about systems of equations, right? So systems, let me just go down here, okay? Or these things here, x plus y equals 7, or maybe 2x minus y equals 12. All right, so this is what we're talking about. This is a system, a linear system. Now, notice we have 2 variables here, x and y. So in algebra, the deal is this. How many variables do we have here? We have 2 variables, x and y. So in algebra, when we have an equation that involves 2 or more variables, you need you need that many equations to set up a system. So in other words, I have two variables, x and y, so I need two equations, okay? I need two equations to solve for two variables. So when you have this kind of setup, if I had an equation with x, y, and z, well, how many equations would I need to solve this particular, solve for x, y, and z? Well, I would need three separate equations, okay? And that's just generally how it goes. And these are systems. This is a system, a linear system with three variables, so I'm going to need three equations. Here we need two equations. So as you're studying systems, that's kind of, you need to know how to solve these guys right here for this particular problem. Now, again, if you don't know how to solve systems, a couple of suggestions. One, I have some videos in my algebra playlist, but you really want to get into like one of my courses, I would suggest my algebra course. Okay, so that's just kind of some prerequisite work here. And you're like, okay, we're talking about systems, and like this word problem would be in a chapter that you're studying about systems. So we're going to have to create two equations involving two different variables. So just knowing that is kind of a clue on what we need to do. Okay, so that's kind of like all our prerequisites. Now let's get into the problem. So first of all, okay, we read the problem once, kind of have a general idea. We want to know what. Well, how do you know what the question is asking? Well, you want to go to the question mark, and I'm not trying to be funny here, and then back up, okay? Go to the question mark. That's generally a good place to figure out what the question is asking. And the question is asking how many cans of each size were sold. Okay, so how many cans? It's not asking about price, it's asking about the number of cans, okay, of each were sold. So that's what I'm trying to answer. So how many type of cans do we have? Well, we have small cans and we have large cans, okay? So let's go ahead and just establish some variables right off the top of the bat. Let's let x equal the number of small cans, and let's let y equal the number of large cans. Okay, so there's our variables. We have x and y, and now we're going to have to combine these variables. We're going to have to try to come up with two equations, okay, two equations that involve both x and y to form a system, right? So this is kind of a hint, right? Now, how do we do that? Well, that's what all this other information is in here for. We got price, and we have revenue, and we have this other little part of this problem. It says one day the store sold twice as many large cans as small cans. So we're going to have to use all this information by reading and rereading to pull together all this, info into an equation. Now, I told you about structuring this in terms of a model. What works really nicely for problems like this, so you can't like visually, graphically draw this out, but you can definitely use and organize this information into a table. Okay, so let me show you here, and this is kind of a classic word problem as well. All right, so using little tables like this are very, very convenient, and you need to have something just beyond your variables. Okay, all right, so let's take a look at this little table here that I constructed. So we have a category. Okay, we have price. We have the number. So a category is like, hey, we're dealing with two different things. We have a small can and we have a large can. We have the prices of each of those. We have the number of those cans sold, and then we have the total revenue, right? That's the total amount you made from each of those sales of those particular categories. All right, so let's take a look at the small can, okay? We know the small can goes for $8.95. Okay, all this here is in the problem. Okay, so you need to reread it and read it, but I'll just kind of review it from here so we don't have to scroll up so much. So the small cans sell for $8.95 a piece. Okay, so how many small cans do we have? Well, we're saying that we have X number of small cans. Okay, X number. So that's how many sold. All right, so what was our revenue? Well, how many cans we have times the price of that can. All right, that's how much we sold. That's how much money the store made on those cans. So How much money did you make on the small cans? Well, we sold 10, so 10 times 8.95 would be the revenue. Okay, so the revenue is going to be equal to the price times the number sold, right? So hopefully you understand that. And then we could just do the same thing here for the large cans. The large cans go for $15.95 a piece, and we have Y number. We're saying we have Y number of large cans. So how much do we make off the large cans? Well, the number would be Y times its price would be $15.95 times Y. Okay, that's the total revenue for the large cans. Okay, so now what we want to do is we want to start creating equations. Okay, so we have some information better organized. We want to create some equations, and now go back and reread the problem. Okay, start looking for relationships that you can create an equation from. Okay, so here I'm going to go ahead and I'm going to underline the places that you can create an equation, and maybe you can do it as well. So one day the store sold twice as many, okay, this part, large cans as small cans, okay? This is a part of the problem that you could create an equation, okay? And then right here, if the total revenue that day from these cans was $6.94, okay? So these two parts of the problem are going to help you set up two equations, okay? So focus in on that, and then use this, okay? And what you can construct, hopefully, is this, okay? So here is our two equations, okay? So our large cans, okay, we sold twice as many large cans as small cans. So that would be y equals 2x. That's one equation that I can set up, all right? So hopefully that's a pretty obvious one for you guys. And then here, let's talk about the total revenue made, okay, right here. The total revenue that came in these days was $694.45. So we made this much on the small cans, plus we made this much on the large cans. So in total, we made that $694. So we can say, okay, $895X plus $1595Y is equal to $694.45. Okay, so take a look at what we have. We have one equation here involving X and Y, and we have another equation here involving X and Y. So now I can form a system of equations, right? Now I have enough to solve for X and Y, all right? Now, that's kind of a different phase of the problem. So here is our system involving X and Y. So this is where you need to be able to have your skills, right? You need to know how to solve systems. Okay, now if you can't solve this, if you're like, yeah, I'm not even sure I can do this by, right now, I couldn't, if you gave me this as a problem, not even the word problem, then if you can't solve this, then obviously you need to improve on solving systems, okay? Get that, down, and then come back to these word problems, all right? All right, so let's go in and solve this problem. So this is like the easiest system to solve because we have y is equal to 2x. We have this y here, so we can use the substitution method. I can replace this y, because I know y is equal to 2x, with this 2x. This is called the substitution method. But basically what we're trying to do is create one equation with one variable, okay? So that's what we want to do when we're solving systems. So in other words, I want one equation with all x's, I don't care, or one equation with all y's, then I can solve for x or y. But I can't solve with x and y together like this. So I can replace this y here with the 2x, because y is equal to 2x. So instead of writing y, I can just plug in a 2x there, and then I have one lovely equation with x's in it, and I can solve for x. So that's what we're going to do here using the substitution method. And let's get into it. So y equals 2x. I can replace this y again with 2x. And you can see the work here. I have 895x plus 1595 times 2x gives me 31.9x. So we have 895x plus 31.9x. And I can add these like terms. So that's 40.85x is equal to my 694.45. And I can use my calculator, not a problem, to do the division here. 694.45 divided by 40.85x will give me x is equal to 17. And I would expect an integer value because we are talking about the number of cans, right? So are you going to sell 1.8 cans? No, that's not going to really work, right? You're having these discrete values in 1 can or 2 can or 3 can. So that's what x is equal to. Okay, now remember x has a meaning for us, but let's go ahead and solve for y. So I know y is equal to 2x, and I'm like, ooh, I just solved for x, so I can just replace this x with 17. Okay, so y is going to be equal to 2 times 17 or 34. All right, so now we know what y is equal to. Y is equal to 34, and x is equal to 17. But what is that, right? Remember, x was equal to the number of small cans. All right, so that's what 17 is. That's what x was equal to, remember, okay? And then y was equal to the number of large cans. Remember, we sold twice as many large cans as small cans, and that's going to be 34 large cans. Okay, so that is the answer. Now, if you were able to do this all on your own without assistance from me, then definitely give yourself a big smiley face. Maybe have your hair standing straight up, an A plus, a 1000%. Matter of fact, if you were my student in class, I'd say, just take the book, go home. You don't even have to show up for the rest of the year because you are awesome. You're taking notes, you understand this stuff. You must be watching that guy on YouTube. It's where, somehow, some way, you're just like acing your math course here. So, that's very impressive if you're able to do this problem. Now, if you were struggling with parts of it, but you understand, what I did, then that's excellent as well. But don't confuse watching someone do math, watching your teacher do math, or watching me do math, and you watching it and go, I understand how they're doing it, therefore I understand. No, that's not the case at all. Okay, don't be deceived in this manner. So one thing you could do is you can do this problem on your own. Okay, don't want you saw me do the solution. See if you can recreate the solution all on your own without looking at the video again. And if you can come up with the correct answer, then obviously that is much better than just watching the video. All right, so again, we're definitely not into sad faces when it comes to learning mathematics. Okay, the whole idea behind me making these videos is to get you to have a happy face when it comes to learning math, but you got to do your part, okay? You got to put effort in, you got to work hard, you got to take great math notes, and if you're having trouble, in class or understanding stuff, then get the extra help you need. Hopefully, that can be me, helping you. All right. My passion is to teach math in a clear and understandable way. So if you like my teaching style, then please consider subscribing to my channel and make sure you like this video. Smash that like button. That helps me out. Again, if you want my best help, you want to definitely check out my Math Help program. For systems, for this type of level of math, I would suggest like my Algebra 1 course. But if you're taking college algebra, you're going to be studying systems. Pre-algebra, you have like an introduction to systems. Algebra 2, you're studying systems as well. So any of those courses all have systems chapter in there. So that's my suggestion there. But again, don't forget that I do have additional videos, many videos on solving systems in my algebra playlist. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.